Hey YouTube, what's going on? You're on gradients, tangents, and normals. That's exam styles questions part 3. Make sure you watch all previous parts where I explain all other different problems, medium and actually hardest level. So make sure you can do that. Pause the video, try to do by your own, and let's get started. So you have to find basically the coordinates of the point of intersection of the tangent line at one point to the curve with the normal to the same curve but at probably different points. I just briefly try to draw up the situation in this case. So let's pretend that this is the curve fx, okay? That's your curve, and you have one point and let's say probably another one, okay? So what are you gonna do? You just need to put the tangent line at one point. In this case, it's going to be 3 and 3 minus square root of 6. Let's pretend that's the tangent at the point 3 and 3 minus square root of 6. And here's going to be the normal, okay? So the normal line would be there. So maybe just let's rearrange the points so that to clearly show that tangent will be intersect with the normal line. Let it be the normal line. Here is your point. That point is 0.5 and negative 0.5. That's your point of when the normal goes through, when the normal goes to the curve with fx. And here is the point of intersection. So normal line will intersect, that's intersection sign, with a tangent. So at some point, let's say P. And you simply need to define that coordinates. So this is the visual presentation, and let's do it algebraically. So what we need to do first, we need to complete the general equation for the tangent line. Let's set up as y minus y0 equals to f prime at x0 times x minus x0. Okay, so that's the general equation for the tangent line. So x0 and y0, basically the coordinates where the tangent occurs or touches the curve fx. So in this case, it's going to be 3 and 3 minus square root of 6. Okay, what we're going to do right now, we need to define the derivative f prime or df dx in that case. So we're using the equation for fx. We need to define the general equation for the first derivative. So we differentiate x minus, instead of square root of 2x, I'll split them as square root of 2 and times square root of x, but I'll represent as x 1 over 2. We're taking the prime now. It would take, using the rule for differentiation, we'll get 1 minus square root of 2, and maybe I'll write like this, square root of 2, then 1 over 2 goes there, means 2 in the bottom part, and x becomes with the power negative 1 over 2, so that means we'll have the square root of x in the bottom part. But I will rewrite as the following, 1 minus, and square root of 2 over 2, I'll write as the whole single stuff as square root of 2x. Okay, so we have the f prime at x, and now we need to plug our point, which is 3. So we need to find f prime at 3. That first, what we need to do, just plug 3 there, and we'll get 1 minus 1 over square root of 6. Then we calculate, so approximately is going to be around 0.592, but I'll round up to 2 decimal places. So to 2 decimal places, all right? So that's f prime. So that's why the general equation for the curve, for the tangent line is going to be y0, that's 3 minus square root of 6. If you calculate that, you'll get 0.55, around 0.55. That's y0, okay? And on top of that, we need to use 0.59 times x minus 3. Okay, that's going to be the equation for the tangent line. We've got this equation. If you like, you can round up because you can simplify even more. and we'll get the equation for the tangent line as the following. 059, that's the gradient, x, and here is going to be around -1. Let me simplify that. 055 minus 3 times 059. So what I've got around 122, okay, 122 with a minus sign. Okay, so that's going to be the general equation for the tangent line. And now we need to establish the equation for the normal, all right? So what's the difference? If we try to find the equation for the normal, we works almost the same. So in this case, I'll take x1 and y1 point on the curve at where we taken the normal, okay? So it's going to be 0.5 in our case, 0.5 and negative 0.5, okay? So that's our point according to the statement. So that's why x1 and y1, that's going to be corresponding coordinates. So what about the gradient? The gradient is going to be a reciprocal one as what you have for the general equation for the tangent line. So that's going to be negative 1 over f prime at the point x1, okay, times the same x minus x1. Okay, so that's why if we know that the general equation for the derivative f prime is going to be 1 minus 1 over square root of 2x, so f prime from x is going to be 1 minus 1 over square root of 2x. Let's just first plug the coordinates x equals 0.5 right there. And let's calculate first the derivative f prime at given x coordinates. It's going to be 1 minus 1 over square root of 2 times 1 over 2. That's going to be 1, okay? So just plug there and you'll find out that if you multiply, you'll simply, by subtraction, you'll get 0. So what it means, because right now that's not you are not eligible to divide by 0, but if you do that, you'll get y be will have uncertainty because it's going to be minus 1 over 0, which gives you negative infinity in general. So what it means, so the gradient of the normal line is undefined. Okay, so what it means, which sort of the case it might be, it means that the normal is simply a vertical line. So that's the normal line. So normal line is going to be a vertical line. So that means the general equation for the normal line will have the general equation when x coordinate is fixed only. So y can be any. So that means x is going to be 0.5. All right, what you're going to do right now, you need just simply to combine with the equation of the tangent line in order to solve simultaneously. Y equals 59x minus 1.22. So what it means simultaneously, because you're looking for the common point. One more time, let's go back to the graph. So you're looking for p coordinates x0, y0. That's the common point of intersection normal with the tangent line. So that means simultaneously solve for, in this case we know x because that's an equation for the normal, and we already know the x0 coordinates of the point P. So solve for y now. Okay, what we're going to do, we just need to plug 0.5 there, and let's calculate. So 0.59 times 0.5 and minus 1.22. So what I've got y0. So y0 is going to be negative 0.925. So that's normal line, so that's the tangent line, and here is the point of intersection, okay? So let's have a look graphically. So graphically, I already preset up. So this is fx. It goes this way. It's sort of pink with dashed yellow color here. So this is our function. So that's the tangent line. Here's the tangent line. That's t. So tangent. However, for some reason it's 23, so I think it's going to be 22. Okay, but anyway, so just need to correct in order to get the proper number. So 22. Okay. Oh, finally. Okay. Anyway, so you understand that it's 1.22. So that's the equation for the tangent. So tangent at some point at the point 3, right? Yeah, it's right there. So this is the tangent, and here is the normal line. So this is the normal line with the equation x equals 0.5. And here is the point of their intersection, so point P with the coordinates 0.5 and let's say negative 0.925. Okay, so we've got that point. So here, this point is there, and we definitely know that this is the vertical line, so normal line is perpendicular to the x-axis. So that's the graphical visualizing, how you can see that. But actually, you can do without any imagination. So imagination is just the way you can test your answer and test for errors. All right. So hope you like that. Don't forget to check all other videos in the series for A-level, also GCSE stuff, also general physics. You're welcome, guys. Any comments, please share below the video. And don't forget to check A-level, Zillion's classes. That was me, and peace out.